Example 3 asks us to use the calculator to generate the first 5 terms of the sequence with a starting value of 5 and the rule double and then subtract 3 to find the next term. So what that's meaning is that we have a sequence with the first number 5, the first term is 5, and we need to find the next 4 numbers in that sequence. The easiest way to do this is with a calculator. So on your calculator, if you tell the calculator that the first term is 5, you need to hit the number 5 and then enter. By doing that, that just tells the calculator that 5 is the first term. And then I'm going to tell the calculator now what the rule is, and I want to double, so times 2, and then subtract 3. When I hit enter, that calculates the second term of the sequence. When I hit enter again and again and again, it calculates the third, fourth and fifth terms of the sequence really quickly and easily. So if I'm going to write the sequence is 5, 7, 11, 19 and 35. So very quick and easy thing to do on the calculator. So now we want to formalize that a little bit and use what we call a recursion relation. So the recurrence relation is just a more formal way of doing what we just did with the calculator. So we need to mathematically be able to write down a starting point and mathematically be able to write down a rule to calculate the next and the successive terms in that sequence. So in this example in the box here, the first term is 10. V0 is the mathematical way we would represent the starting point. And the rule, the way I'd write that mathematically is to write Vn plus 1, meaning the next term, is generated by taking Vn, which is the current term, then adding 5. So if I was to write it as a recurrence relation, I need both parts. I need the starting value, so V0 equals 10, and then I need the rule. So Vn, the next term, is equal to current term plus 5. So if I was writing that sequence, I know that I start with 10, and then to get the next term and the next term and the next term in that sequence, I know I take the current term and add 5. Now 15 becomes the current term, so I take the current term and add 5. Now 20 is the current term, so I take 20 and add 5. And so on and so on and so on. So each time I do that calculation, I'm performing a recursion. So example 4 asks me to do a similar sort of thing. So writing down the first 5 terms of the sequence defined by the recurrence relation, showing the values of the first 4 iterations. So all that's meaning is write down the first term and then the next 4 values of the sequence. So reading the recurrence relation, I know that V0 equals 9, so that means the first term of the sequence is 9, and then the rule to find the subsequent values in that sequence tells me to take the previous term or the current term and subtract 4. So 9 take away 4 will give me the second term. Then I take away 4 to give me the third term, take away 4, and so on. So again, the easiest way to do that quickly and effectively is on the calculator. So first term 9, hit enter. My rule is subtract 4. So I need to go subtract 4. Enter, 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 enter. So my sequence is given by the terms 9, 5, 1, -3, -7. So example 5 is just a slightly different way of asking a similar kind of question. So it tells us a sequence is generated by the recurrence relation V0 equals 300. So 300 is the starting point. Vn plus 1, so to get the next term, I multiply the current term by a half, and then I subtract 9. So doing that in the calculator, if your starting term is 300 and enter, my rule is now multiply by a half, so multiply by 0.5, subtract 9. Now this one isn't write down the next 5 terms or anything like that. This one says how many of these terms are positive. So what I need to do is just keep hitting enter, 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 enter until I hit a negative number. So in that sequence, the terms 300, 141, 61.5, 21.75, and 1.875 are all positive. Then the next term is a negative. So I need to count how many positive terms are in that sequence. 1, 2, 3, 4, 5. So my answer to that one is that there are 5 positive terms in that sequence before I hit the negative one.